when you're doing the graphing. That's why you get in the graph paper today. You're going to have to make sure that the lines are nice and straight and those types of things when you're graphing those different equations. So just a reminder, you've done systems of equations before. It is not new. A system of equations is a set of two or more equations with the same variable. So those of you that like to write definitions down, a system of equations is a set of two or more equations with the same variable. I'm sorry. So we've got in this case, y is equal to 3x minus 1, and y is equal to negative 1/2 x plus 6. So we've got two equations with the same variables. What we want to happen when we have a systems of equations is we want to make sure that we have a solution. The solution to a system of equations is the ordered pair xy that works in both equations. So we're looking for a point on the lines, in this case, y equals 3x minus 1 and y equals negative 1/2 x plus 6, that they have the same solution. In other words, where they intersect. So we're looking for an intersection of two graphs, or the intersection of two lines. In this case, the solution for this example is 2, 5. So these two graphs are going to intersect at 2, 5. Our goal through this whole unit, or at least this week, is how do we find that solution? And today we're going to find this solution by graphing. So we've got these two equations that we are going to graph. Y is equal to 3x minus 1, and y is equal to 1/2 x plus 6. So what we're going to do on our coordinate plane, so your guys' is nice and neat, mine is not. And you have to be very, very accurate when you're doing these because we're looking for this point that's the point of intersection. And if you're not very accurate with these, it could go in a bunch of different places. So we're going to start out by graphing the first one. Y is equal to 3x minus 1. So that's going to be the first one, and I'll do that one in blue. We've talked about this before, so we're going to go over it quick. The y-intercept is negative 1. So we've got a point at 0, negative 1. So that's our y-intercept. So on our y-axis, on the graph paper that you have, that's why I supplied you with the graph paper. On the graph paper that you have, on one of them, put a point at 0, 1, negative 1. That's our y-intercept. Our slope of this, our slope is 3, but we always have to have a rise over run. So we're rising up 3, running over 1. So we're going to go up 3 over 1 and make us another point. Again, make sure you're accurate. That should be at the point 1, 2. Okay. And then you're going to take and you're going to draw a straight line through those 2 points, as straight as you can, through those 2 points. It means you need to take out a calculator case or something else to make it straight, make it straight. So that's the graph of y equals 3x minus 1. The next one we have to graph then, and I'll graph this one in red, we have to graph the second equation, y is equal to 1/2 x plus 6. And we're going to do it on the same exact graph. Because ultimately we're looking to where these intersect each other. So my y-intercept is my b value, so 0, 6. So at 0, 6, remember 0 left or right, up 6, I'm going to put a point. The slope of this is negative 1/2. So I'm going down 1 and over 2. and I'm putting another point. Again, mine is not accurate here at all. Okay. And I'm going to draw a line through it. This point right here, that is my solution to this system of equations. And again, mine is not accurate at all. Yours should be far more accurate than mine is. But that's the 0.25. And again, the only way I know it's 2.5 is because that's what it told me it was. On your graph, it should show that it's at 2.5. Does it show that it's at 2.5 on your guys' accurate graph as opposed to my inaccurate graph? That's why, and I kind of do it this way with me just sketching it for a reason. This is the least accurate way to do these, to find the solutions, especially if you're graphing them, because you have to be so accurate. I would have no idea that this is at 2.5, because really my 5 is like right here, so mine is all kind of messed up, but that's just kind of the way it goes when you're trying to sketch things, okay? But ultimately what we're looking for when we're solving the system of equations is we are looking for this point right here. That's the point that they have in common. So if I plug this point in, 2.5, my y value is 5. That's going to be 3 times 2 minus 1. 5 is equal to 6 minus 1. That works. 5 is also equal to negative 1/2 times 2 plus 6. Negative 1 plus 6 is 5. It works. So that's what we're looking for. We're looking for a solution that works if I plug it into both of those. And it does. Right? Let's look at another example. Let's go with y is equal to negative 2x minus 1. And y is equal to x plus 5. So to solve this system, we're going to do 2 steps. We're going to graph both equations on the same coordinate plane, and the solution is going to be where those lines cross. If they cross. They might not. They don't have to. So I'm going to do this one in orange. So my y-intercept is 0, negative 1. This is the one we just did. So our y-intercept is 0, negative 1. Now I've got graph paper on this one, so I should be a little bit more accurate. I have to put a point at 0, negative 1. My slope is negative 2, so negative 2 over 1. So down 2 over 1. I'm just going to put a few more lines in here just to make sure it's accurate. There's a graph of my first one. Now I'm going to graph the second one in purple. So I'm going to graph y equals x plus 5. My y-intercept, 0, 5. My slope, 1, 1, so up 1 over 1. I don't appear to be too accurate again. My graph should be more. My orange line still isn't very accurate. So there's my orange line. There's my other line. They meet right there. Okay, so again, these are hard without straight edges. So that point right there is going to be my solution. Negative 2, 3. Is that what everybody else got? If you look at your graph, negative 2, 3. Those of you that were far more accurate than I am with this. So get another one. Okay, so let's look at y is equal to negative 4 and y is equal to 2x plus 4. We're going to solve this system. We should be able to figure out what the y is. Y is already given to us. Start with the first one. Y equals negative 4. Remember what we've talked about tons of times. We need 2 points to create a line. The y value always has to be negative 4. I don't care what the x value is, but our y value always has to be negative 4. So I've got 0, negative 4, and I've got 1, negative 4. A line that I can draw straight, kind of. That's that one. The second one, the y-intercept is 0, 4. It's my b value. My slope is 2, 1. So that means I'm up 2 over 1 or down 2 over 1. And I'm going to kind of cheat here a little bit. Everybody see what I did and how I did this one? So what I did is I drew my initial line. And then what I did with this second one is I just made all of them. I was either up 2 over 1, up 2 right 1, or down 2 left 1. Okay, that's all a positive slope. And now you notice when I did that, I still can't hit the lines, but I have the intersection point right here by connecting them. We look and see what that is. It's negative 4, negative 4. This is our solution. And again, if I plug those in, it should work, and it does. Questions so far with graphing? Well, what happens if we have something like this? How do we go about solving a system that looks like this? We've got 2x minus 3y equals 3, and negative x plus y equals negative 2. So let's concentrate on the top one, 2x minus 3y equals 3. What should I do with that first? Minus 2x, because what ultimately are we going to do? Solve for y. So I'm going to rewrite it just so I have it. So I'm going to subtract 2x. So that gives me negative 3y equals negative 2x plus 3. Now what? Divide by negative 3. Divide everything by negative 3. So that gives me y is equal to a negative divided by a negative is a positive. 2/3 x, 3 divided by negative 3 is minus 1. Now I have it in a nice form. 2/3 x minus 1. It makes life a little bit easier. Now we know the y-intercept. Y-intercept is 0, negative 1. I put a point at negative 1. My slope is 2/3. So up 2 over 3. So there's the graph for that one. Let's go to the second equation now. What am I going to do first? What am I going to do? Add x. Very good. I'm going to add x. So that's x minus 2. we're good to go. So my y-intercept is 0, -2. My slope, what's my slope in this one? What's out? 1 over 1. So up 1 over 1. So it looks like they intersect right there. At that point right there. That is the point 3, 1. So we've graphed equations in the past. This is not new. Just need to take your time, make sure you get them in slope-intercept form. And again, be as accurate as you can with these. There's wiggle room, I get it. They're a little hard sometimes to tell where they are. But ultimately, it works out okay. Go ahead and try this one. Work with partner, give you about 2.5 minutes. See if you can find the solution to that. Again, work with partner, see if you can find a solution to that system of equations. Solve for y first. Trick question a little bit. Do they hit each other? No, what are they to each other? They're parallel to each other. So do they have a solution? No, these don't have a solution. A couple ways you could tell. Obviously, some of you graphed it. So the first one, we would have 2y equals negative 5x plus 8. So y is equal to negative 5/2 x plus 4. Does that look like what the first one should be? So we've got one at 4, and we're down 5 over 2. So it looks something like this. The second one, that'd give me 2y equals negative 5x minus 6. So y equals negative 5/2 x minus 3. Did everybody get these pieces okay? Sure. So we've got negative 3. Now the slope, it's negative 5/2. So I don't have enough. So I can go up 1, 2, 3, 4, 5, and over 2. If I could do straight lines, these are running the same way. So they're never going to intersect. So therefore, there is no solution to these. No solution. You could look at it right here. If they have the same slope, but different y-intercepts, they're going to be parallel to each other. Okay? And there's going to be no solution. So there are 2 special types of cases that you could have. You could have if the lines are parallel, which we just did. If the lines are parallel, there's no solutions. They don't intersect each other. You could also have one that are the same line. Okay, so if you got y equals, it's going to be exactly the same thing. Y equals 3x plus 4 and y equals 3x plus 4. If they're the same line, there's infinitely many solutions. Doesn't mean that everything's going to be a solution. It just means if it's a solution for one, it's going to be a solution for both, and it's going to be all cases. So if I give it an x value for one of them, its y value is going to be the same for both of them. Okay. Any questions with graphing to solve systems of equations? All right, homework for tonight. You do have a worksheet. You have worksheet 1A. Obviously, I want you to be a little bit more accurate with this one than we are in the past. So I do have this worksheet. I would suggest you get this. It is inside of Schoology as well. So you do have that. But the worksheet is right there for you to use. Got the rest of the hour. Get it done.